Okay, from a point A, due north of a tower, the angle of elevation to the top of the tower is 45 degrees. From a point B, 100 meters on a bearing of 120, from A, the angle of elevation is 26 degrees. Find the height of the tower. So often with these type of questions, they're actually giving you got to look at it as you're getting two scenario situations in terms of your drawings. So what I like to do first is maybe do the flat drawing. So this is if we were like looking at it like as if it was a map or a bird's eye view. So you've got from a point A, which is due north of a tower. So I'm going to draw in a little tower, and then I'm going to say that there's a point A which is due north. So I know there's A and it's due north. When they give me the angle of elevation scenario, so the angle of elevation to the top of the tower, that's another type of drawing. So maybe I like to call it the 3D drawing. So if I was thinking about what's going on, I've got a tower and I've got point A, and to the top of the tower is an angle of elevation of 45 degrees. So I'll draw that in there. Okay, then the next point, they say that from point B, 100 meters on a bearing of 120 from A. So I'm going to do the 120 degrees from A would be something like that, around here, 120 degrees. And they're saying point B is like out there, and we're saying is 100 meters, okay? So at the moment, sorry, just fixing that up. At the moment, we know there's point B, so I might draw a little compass in there, and I've got point B. So a few things we know, that's 120 to there, up to this line. So because it's got to be 180, we might say in there is 60 degrees, we know that. Okay, now they give us another sort of 3D option where they say that the angle of elevation to the tower from B up to the tower is 26 degrees. So we know that. So what we're going to look at here is, if we think about it, the distance we have from the bottom of the tower to A, so I'm drawing that in pink along here, is what we've got there. That's that pit there. So I might call that X. Okay? Then if we're thinking about what we have for the other scenario, so which was, we've got from the tower, bottom of the tower to B, what we've actually got, that's that line here, and I might call that Y. So that's Y there. So if you look at what we've got, we could set up a few scenarios. So really what we have here, if I just drew the triangle a little bit more simple without all the bearing parts on it, I've got X, Y, I've got 100 meters on that bit, and I know that angle is 60 degrees. Okay, so if I was labeling this up like we normally do, might label it A, B, C. Oh, actually, I'll just, to help us out, I might call that A, that B, and that C, so it matches. So really we've got B, little a, and little c. So say I was trying to find out what this y is, which is in green, I could use my cosine formula where I say a squared equals b squared plus c squared minus 2bc cos a. And so really what I could say, and I could change it all, and I might make it y, and see how it's squared. So I can just get 1y, I can just say square root. And I'll put all the formulas. So for us, b is x squared plus c is 100 squared minus 2 times x times 100 times cos 60 degrees. Okay, so now what I've got is I have one rule, or one equation I should say, with one unknown of y and another unknown of x. All right, so I've linked that together. When you have two unknowns and in an equation, what you actually need is then you need two equations to be able to solve it. So this is equation 1. So I need to be able to set up another scenario using x and y to try and get the second equation. So if I go over to this 3D diagram over here, I've actually got right angle triangles. So if I look at this one, we said before this is x and there's y. So if I was trying to find x, I might use opposite over adjacent, because in the end we want to find the height of the tower. So I'm just going to call it h for height, and that would be the same here. Okay, so if I was using this triangle here, I might use the tan rule because it's tower. So tan 45 equals the height over x. If I rearrange that to get that by h by itself, it would be x times tan 45 equals h. And I'm not sure why they popped it in here, but they have. But you probably need to know that if you actually type tan 45 into your calculator, you'll find that that actually equals number 1. It equals 1. So you can essentially say that x, because it's x times 1, which is x, equals h. So if you know that x equals h, then this, you know that this is also x and this is also x. So instead of calling the tower h for height, I'm now calling the tower x because it's the same distance. So knowing that, see here, I can now link x and y because this is my opposite and this is my adjacent, and I'll use tan again, and I'll say tan 26 equals x over y. And if I was trying to get y to be, you know, I'll rearrange it, it'd be y times tan 26 equals x, and then I can say y actually equals x divided by tan 26. So now I have my second equation here. So equation 2. So really what I can pop into the calculator now is I can use the solve function, and because that's a y and that's also y, I can just simply let them equal each other. So I can go solve. I'm going to say x over tan 26 has to equal this other y, which we worked out because it's the same thing, plus 100 square minus 2 times x times 100 times cos 60. Okay, and you do comma x, sorry, just squashing it in, and we'll find out what x is equal to. Okay, so we get x to equal, rounding, but 42 meters. So because x equals the height, we can say that the height of the tower equals 42 meters. Okay, A and B are two positions on ground level from an advertising balloon at a vertical height of 750. A is observed in an easterly direction and B is on the bearing of 160 degrees. The angles of depression A and B as viewed from the balloon at 40 and 20 respectively. Find the distance between A and B. So once again, we are going to do those two types of view drawings. So I'm going to do like the flat, map view, if you think about it, and look at that first. So we've got, the balloon. So A and B are from this ad balloon. So I'll just put a little thing, and I'm just going to call it the ad, whatever. There you go. And it says, so I'm not going to worry about the vertical height at the moment because that's the other drawing. But A observed in an easterly direction. So easterly is out. We go, here's A. So I'm going to put my little compass. We've got A. And B is at the bearing of 160. So if I'm thinking about 160, they'll be out this way. And I'm going to draw, so out goes B. And I might just draw a little compass in there in case I need it. So B. So I know that that green line was 160, so I know that in here must be 70 degrees and things like that. So find the distance between A and B. So the question is actually that. So there's the AB, that's the question. But we need to go look at what we've got. We've got 3D views of what's happening, or we get some information using the 3D views. So let's have a look. So you had the balloon ad, whatever, so the balloon, and then point A was out somewhere, and they said the balloon was 750 meters above, and it said the angle of elevation up to the balloon from A was 40 degrees. Okay, so if we're looking at what we got given here, this distance from the bottom of the balloon to A is this distance along here. So I don't know, I'll just call it Z. There you go, Z. Okay, and if we look at the other 3D scenario they gave us, so they gave us the little ad balloon, and they said B was from it, and they said the angle of elevation from B was 20 degrees. So this is still 750 meters above. And so if you look at what we've got along the ground in terms of the balloon, bottom of the balloon, and point B is that point here, where that's actually this part along our map. Okay, from the ad to the balloon. So I might just call that, oh no, I'm just going to call that Y. So there's the Y. So we need to be able to find over here, I'm calling AB X. Okay, so I've called that X. Alright, so if we could look, we just made our little triangle a little bit more simple. We've got Z, we've got Y, we've got that 70 degrees, and we've got X. So I need to get Z and Y to be able to use the cosine rule. So maybe I'm going to go over here and look what I can use. So I can set up tan again, because I've got opposite and adjacent. So I can say tan 40 degrees equals 750 over Z. So you can use your solve function for that to find that. So we can just go solve tan 40 equals 750 over Z, comma Z, and we get Z to equal something. So I get Z to equal 894 if I just round to meters. So you now know over here this is 894, and then I can just do the same thing again but with this. So tan 20 equals 750 but over Y, and I'll use the solve again and I'll find out what Y is equal to. So Y ends up being 26.1 meters. So this triangle over here, so I'm just gonna rub it out, make it a bit bigger. So we've got this big triangle like so. We were calling this B, this A, and the ad, which now I might just call C, so I can get them, use my formulas. Now I know this is Z, which is 894 meters. I know this is 70 degrees, and this one's Y, which I know is 2061 meters. So I'm trying to find X here, which would be little c in my case. So this is little b, little a, so I can use the cosine rule, which was c squared equals a squared plus b squared minus 2ab cos c. And you can see I've got everything else there, so I can say x squared equals 2061 squared plus 894 squared minus 2 times cos 70, and you can always put solve, comma x, we're going to find out what x equals. So yeah, x to equal 1946 meters, which for me is what AB is. So AB, just to answer the question, is 1946 meters, and there's your answer.